Yes, dear friends, we have learned till now that focal length of lens depend on radial curvature and reflex by equation 1 upon f equal to n minus 1 into 1 upon r1 minus 1 upon r2. If it is convex lens placed near reflex n, radial curvature r1 and r2, then its focal length depend upon n, r1 and r2. N is the index of length with respect to air. So, if this lens is placed in any other liquid, suppose it is dipped in a liquid of index n dash, then like oil or water, then how the focal length would be affected, we have to see that. So let we have length of focal length f in air. It is given by this equation. Now if this lens is dipped or submerged in a liquid of reflex index n dash also with respect to air. Suppose here it is a liquid here and we dip it into this. Then how the focal length will change? Focal length. Now light will be going from liquid to glass and liquid. To use lens maker formula, we need the index of lens with respect to liquid. So if f dash be the focal length of lens in liquid, then 1 upon f dash equal to. So we need index of lens with respect to liquid, and I have told you it is equal to n upon n dash minus 1 into 1 upon r1 minus 1 upon r2. It is n dash. I have told you many times the index of materials are given with respect to air. If you want to find out index of glass with respect to water, Wng, it is A and G upon A and W. So here A and G are taking N and N dash is this. This is equation 2. Now if we divide 1 by 2, divide equation 1 by 2, we will get f dash upon f, dividing equation 1 by 2 is equal to n minus 1 upon n dash minus 1. Simple. R cancel with n. Now f dash is equal to f dash upon f, n minus 1 upon n dash LCM n minus n dash, or f dash will come out n minus 1 into n dash upon n minus n dash into f. This is very important relation. used many times. Hai bhai? So you please learn this thing. F dash is the focal length of lens in liquid, while F is the focal length of lens in air. You know reflex varies from material to material, from color to color also. For a given glass, different colors have different refractances. For a given glass, different colors of light have different value of refractive index. Now, so I write here f dash equal to n minus 1 into n dash. नहीं दिख रहा. F dash n minus 1 into n dash upon n minus n dash into f. Equation 3. Now, here I want to discuss number one thing. If n greater than n dash, so numerator will become less than 1 but remain positive, then f dash will be greater than f, and nature of lens remains same. That is, convex behave concave convex, or concave remain concave. Number 2, if n is less than n dash, so this become negative, and this negative also value less than 1 modulus, so f dash will be negative and longer than f. Hence, nature of lens gets changed. Means convex become concave, or diverging become converging as diverging. Number 3, if n equal to n dash, denominator becomes 0, so f dash infinity. If focal length becomes infinity, it means radial curvature have become infinity, and it becomes the lens will like a plate of the liquid, or you can say it will not be visible in the liquid. Lens liquid में invisible हो जाएगा. So we can understand all these things by diagram here. Here it is a convex lens, suppose, means converging lens, with index n, and it is placed in a liquid of index n dash. Now these are parallel beam, parallel, so they get focused here. This is one case. Another case here, again convex lens, n and n dash, n dash. Now parallel rays. Remember, figure to convex, but nature is converging. But now rays go like this. मतलब lens behave like diverging. Third one, n dash. Parallel beam goes undeviated. So you may be asked how n or n dash are related. Because converging nature does not change. So here n greater than n dash. Here nature has changed. But according to this formula, f dash equal to n minus 1 into n dash upon n minus n dash into f. If n dash less than n, f dash, if it is positive, so f dash positive, negative, so negative. Here, nature has changed. Converging lens become diverging. So n dash, n less than n dash. And here n equal to n. Same thing happens with diverging lenses. If we have diverging lenses here, you can see the diagram further. Diverging lens different dash n dash medium, parallel beam. F diverge from a point here. So here again n greater than n dash. If it is diverging lens again, but parallel is converge somewhere. So now n dash, n or n dash. So here n less than n dash. And similarly, if this figure look like this, so parallel, beam remain parallel. So n dash, n. So n equal to n dash. So nature of focal length, nature of focal length and nature of lens depend on medium also. If we place the lens in a liquid rather than air, so naturally focal length will change. And focal length decides also the extent of convergence and divergence. Now I come to next important point here. I will be telling numericals just now here. Power of lens. Power of lens. Yes, dear student. Purpose of lens. Why do we use lens? Their aim of using the lens is to convert or divert a parallel light, and greater the ability of converging or diverging the parallel beam, greater the power of lens. So the ability of a lens to converge or diverge a parallel beam of light. The ability of lens to converge or diverge a parallel light The ability of a lens to convert or diverge apparent light is the measure of power of lens. Conversely, you can say power of lens is the ability to converge or divert. Shorter the focal length of lens, shorter the focal length of lens, greater will be the ability to converge or diverge the parallel beam of light. Let us see now. Suppose is the one lens. It converges here. Suppose at distance of 20 centimeter. And is another lens. It converges here at 10 centimeter. It is at distance 20 centimeter. It is at 10 centimeter. So who is converging more? The lens of focal length 10 centimeter. ये focal length होगा ना, but focus of lens defined as the point where a parallel beam after refraction through lens really converge or appear diverge. So power of lens. So power of lens is equal to reciprocal of focal length of lens. So if small f be the focal length of a lens, then power of lens is given by P equal to 1 upon small f. P equal to 1 upon small f. Reciprocal focal length. If focal length is measured in meters, unit of power of lens is diopter. Known by capital D. If focal length is taken in meter, the focal length is taken in meters, then power will be in diopter. Generally, we do mistake focal length 25 centimeter. So what is power? Make 25 centimeter as a meter. So it will be 4 diopter. And power, since focal length of convex positive and concave negative, since focal length of convex lens is positive, so power of convex lens is taken positive, and focal length of concave is negative. So, power of concave lens is negative. So this was about the refraction through lens, relation of focal length with radial curvature. Remember, focal length depends upon radial curvature as well as different index. We will meet with next topic.